East Sweden Game.
I'm going to talk about music and AI, and more specifically about how you can use artificial intelligence to create music. This is the overview. First I'm going to go over some background to this project, and then I'm going to discuss various problems in music that you can solve or AI can help out with. And then I'm going to show how to solve them with my latest prototype system called WaveBots, which is a music AI. Then I'm going to talk about some applications of music AIs in this context, and then talk about something called WaveBots Hub. That's a system I'm working on right now. And then we can have some questions and maybe some discussion. So I went to D-linjen here in Linköping and continued with as a PhD student working with planning, knowledge representation, and unmanned vehicles. Those of you who were at the Linköping AI launch, Fredrik Heinz showed a video, and I was actually working with him on that project with those unmanned vehicles. And I've also been working with game development, publishing my own games, and also working with Thomas Ahlström, Martin, and Magnus on their Bloxworld game. Then I also been doing a lot of procedural generation stuff, like generating textures, 3D models, sound effects, and also music, of course, which is the topic of today. So my so-called procedural music journey started with I wanted music for the games I created. I couldn't compose that myself, so I had two options: either hire a composer, which I tried, which worked really well, also buy music, which also worked fine. Then I did some procedural generation experiments and went on with sound effects, and then I realized that, well, if I snap the frequencies of these generators, it started to sound like music. So maybe I don't have to hire a composer or buy music. I can just generate it with the music theory. So how hard can it be? I thought. So it's very hard. So this the prototype I'm working on now, it's the 9th in row, and here is an older prototype called Reactive Music Language, which used some state machines and some kind of pattern system for generating music. It didn't use much artificial intelligence though, but the prototype before this is called Abundant Music, and that used a lot of artificial intelligence, because I had discovered something then, that artificial intelligence is very useful for generating procedural music. And particularly one problem with the music is very suitable for artificial intelligence, and that is voice leading. So here we have some notes, and we have this piano roll here showing these notes, showing, and those gray notes there are the chord notes, or ackordnoterna. And we have, at every step of the time here, we have 4 notes stacked over each other. The top line is called the lead, and the bottom line is called the bass line. And leading these voices over time, that they both sound good together, and and so they function as independent melodies, is very, very difficult, and it requires a lot of practice. And when you study music, you learn a lot of rules and guidelines for doing this, so that it sounds good. And this is kind of an ancient knowledge from classical music. So, but it's still very important for most of the music we hear today. And if you get this voice leading right, then your music will sound much better. I'm just going to play those notes. Let's see. Yeah, so that's basically these notes you can use as a foundation for more complex music. If you use add more notes to it, that we'll see later how we can do. So here we have maybe the font is very small, but you can see that there are many rules within voice leading, and the grandmaster of this is Johann Sebastian Bach. He's composed a lot of choral pieces that are considered the best. So if you study music theory, you will read a lot about him. Even if you follow all these rules when you're leading these voices, there's still a lot of you can add creativity to your lines. You can say that they move upwards, that they target a certain pitch in the end, and then you can make your phrases sound in a very in different ways. But if you have worked with music before and you discover these rules, and then you might think, well, these rules are just some old guy using. What relevance does it have actually? Is it I use my ears when I compose? I don't need any rules. So that's true. The ears is actually if it sounds good, then it's good. That's correct. But if you find any problems when you're trying to compose something, like that you can't hear some of the notes, or that some of the melody lines that you're composing disappears or makes the listener confused, then you probably have a voice leading problem. So if you know these rules, you can actually analyze your music. Where is it wrong? So it's still useful, even if you don't. If you compose by ears. And it also becomes a lot easier to arrange the music if you follow these rules. And also mixing, which is a more recent invention, where you take this digital music and try to create a single piece of it. If you have voice leading problems in it, it becomes more difficult to fix it in the mix. Voice leading is actually very, very suitable for artificial intelligence, because you can easily formalize these rules in an AI system. So I'm come from an AI background, so I try to analyze this voice leading problem. So immediately they notice that almost all music is so-called sequential problems. That is, if you play something and then you play something more, it's taken in the context of the previous things played. So it's everything depends on what's happened before. So in AI we call it the sequential problem, and we handle it by automated planning system. And since this voice leading problem contains many rules and preferences, it falls into an area called constraint satisfaction of artificial intelligence. That has techniques for expressing these types of rules of voice leading. What complicates things is that some of the rules and preferences are less important. So then you can assign costs of these constraints, these rules. If you break this rule, it might cost you more. So that you follow these rules, it's gonna. If you're, for example, trying to make some preferences for the line yourself, and you say that this must happen, but the system must break some of the rules to do it, then you allow it to do it by using these soft constraints. And this finally leads to automated planning with constraint optimization, it's called in AI. So let's implement that. And WaveBots is my latest prototype. And it's music AI that can solve many types of music-related problems. One of those is voice leading, since that is so important to get the music to sound good. And here's another line composed by WaveBots. And here is yet another one. So I know it sounds kind of boring, but that's kind of this is only the foundation for the music that we can create. So, but we can still, if we export this into a MIDI file and import it into a digital audio workstation, you can still use that material actually. So if you just plug it into an arpeggiator and I've created an example here with an arpeggiator and a simple build. You can just play that. Just using the notes of this line. It's just a bass, a basic bass line that's added. Now we can hear one of the inner voices, the yellow ones. So you can still create something with this, even if it's just an ancient voice leading thing. But if you want to create more stuff like rhythms and like we hear in normal music, we need to something called figuration. And figuration in WaveBots, this works by using these voice lines that we listen to right now, and we treat that as foundation that we're supposed to follow. And then we, first going to say something about figuration. Figuration is about adding notes that either represent or respect or express these voices. Figuration can also be fillers, that just adding notes for rhythmic content and just fill out the song. they don't follow any voice lines themselves. In WaveBots, this is going from the voice line to the figuration line is performing several steps. First is trying to create an abstract line where you only consider what parts of the line is active and passive. So this is because when you stack several of these figurations on top of each other, then you can get into problems where you have many active parts vertically. So in this line, in this abstract line, you try to make this as good balance as possible. And another thing is that you can also figure out how to create repeating notes. So here we have the active passive here first. I don't know how many can see it, but the first box and the third box here is also the same, so it's kind of repeating, and that's very common in music. And those you can solve on this abstract level. Then you go through some more steps and create a basic figuration line. That's often sounds a bit boring because it's just a pattern. And then later we add some modifications to it, like delaying and shortening the notes, just to make it sound more natural. All of these steps are solved also as optimization problems, since they're all sequential problems as well. And they can be expressed with constraints. Okay, so let's listen to a simple figuration result from WaveBots. Yeah, and it's piano. It doesn't sound that exciting, but you can still hear it's good for expressing the rhythm. You can hear the rhythm. But also, I'm working on a system that can also render this as a more retro style song. So this is going to be. I'm just going to play it. Yeah, maybe you yeah, that's some old school techniques there. Maybe you heard some pitch bends and vibrato and so on. That's those modifications that were applied to the melody line, and there were also some effects on the bass as well. Right. So now we're feeling brave, so we can take several of these phrases and try to create a mini song by using this voice leading and figuration procedure. So we can create phrases and we try to string them together into a mini song. Right. I'm trying to emulate here how WaveBots actually is doing the creating a song. So we can start here with a simple song structure. It's got an intro, 2 verses with that are 2 phrases each, and then in between resting area. Very simple song structure. The things you heard here first, the intro and the verse 1A, is treated as a reference here. So all the thing you hear first, and all the other verses are referred to these two. And then we can try to create some abstract relations between these phrases. So this is very small, but the idea is that the verses are connected by this should be similar. The second verse should be similar to the first verse, but also add some development and variation. And the in-between phrase should be also similar to the intro, but add something new to it. Notice how I kind of trying to compose a song on a very abstract level here, and that's how WaveBots actually is working. And then we actually expand those developments and variations, and here we're going to have a contrast as well in the final verse, which is going to be the strongest phrase of the song. So what happens next is that it decides what parts of the song is going to implement these developments and the variations and so on. It has many different ways of doing it. One way is just to add more parts, adding more content to it. Another way is changing the progression. In this case, we're just going to keep the same progression to create the glue that binds the song together. And the voice leading is also very important for creating connections. If you hear the same line twice, you can you know that these phrases belong together. And small variations of that also create interesting. Here we set up a pattern, and then we break it here in the final verse. We're going to make some kind of contrast in the voice leading. And we're also going to create a contrast with the figuration as well in the final verse, just so we can surprise everyone. WaveBots also working with something called subpatterns, so where you can specify where a phrase group is ending, or when a phrase continues into another phrase. So then a different procedure creates connection notes and different things in between. And then we're going to add some global variation just to it. This is very, very similar to how it works actually. But now we're doing this manually. I have an editor where I can specify what parts of the song to be active. Here I've created a very small font that says that it's the figuration line should be same in another phrase, for example. So you're setting up a constraint for those abstract figuration line I was talking about before. And here you can modify the voice leading of the phrases, so you have these higher level composition techniques. And here is the result of the voice leading for the mini song. To the left there you can see that here, can you see my pointer? This note here and this note here are called structural notes. You can create those structural notes, and you can connect the phrases with each other. This structural note is connected to this one. It's saying that this is going to be the same. This one is connected to this one, but here we have a constraint that says it should end on a higher note than this one. So it's creating similarity with some variation. Here you have a repetition almost of the first verse, and here you have this contrast. You expect it to start here, but it starts here instead. So it's a dramatic change in the pattern. It's not so dramatic in practice, I can tell you. We can listen to it. It's a retro style, of course. It's what I like most. Yeah. Oh, into the in-between part. Surprise. Not that much. Oh, yeah, right. Yeah, it's at least a demonstration of how these connections can be made with voice leading, so we can create a contrast. So suppose we have this song now and we like it, we want to use it in some kind of context, but we want to go further because we have all this AI, so we can create maybe several songs that sound similar, but create connections in other ways. So we're moving from a song into a song set of songs. One way is just to try to use different seeds and randomize things like the figuration, using different seeds for that, and also for the voice leading. And but if you start to randomize more and trying to randomizing what parts are actually active in a phrase, then you run into problems like, well, these two shouldn't be active at the same time, and this just creates disjointed phrases. It doesn't sound like a complete song. So you can add constraints then in the same way for voice leading to create connections on where you specify that these parts shouldn't be together, these phrases should be connected together, so they should be similar. And here we should have some kind of build. So we're adding something. We don't have to say exactly what we're adding, but something is going to happen here. We're adding something new. So in this way, we get more songs out of this single song. So when you start adding new figuration types, you really want to specify with categories and relations how they're related. So if you have a figuration line that's just a faster variant of another figuration, then you can specify it with a relation that this one is faster. And then you can have add things like this phrase group should have a development where you increase the rhythm, the rhythm intensity. and then it automatically picks those figuration lines by it's hard to see the real benefit maybe of this, but it's really useful when you're working with this. I also noticed that something I thought I never going to use, like logical inference, it's really useful when you specify relations and the number of things you want to specify relations between grows, then you have to, it's very tedious. Then you can define these logical rules and just have it infer everything for you. That's useful. And then you start to create these constraints, like a build. For example, this phrase should be stronger than this one. And then you can categorize those constraints and create more of those. So finally you can create a more abstract connection that can expand into those constraints, different constraint bundles. So if you have a contrast in the form of changing the harmony, or changing the voice leading like we did before, this abstract relation, if you specify that, you can choose between many different ways, and also expanding the number of possible songs you can get. This, once more, is this. You will also notice that these constraints, it doesn't always match. It's not always possible to do contrast in some conflicting ways. So you still end up in this constraint problem on this abstraction level as well, which you can solve with optimization. And in this way, by building these constraint bundles, you can create similarity, variation developments. Call response is very common in music as well. So here we have the opportunity to create abstract call responses, which is really nice. And surprises, of course. And patterns, it's also very common. So, we have a lot of problem domains that this music AI can solve. We talked about voice leading, we talked about its abstract lines, the figuration problem, these modification patterns, I haven't touched upon these, but rhythm is another example where you can see it as an optimization problem, but it actually isn't implemented like that in this system. It's more a hierarchical splitting thing. These are all within the phrases. Then you have seen couplings and problems to solve between phrases as well. The song voice leading, what's vertically active, progressions. Yeah, I move on here. There are lots of problems that I discovered that trying to create this system, the reason for I even split them up is, if I don't do that, the AI algorithm can't deal with that many combinations. So I really had to split it into these. And up here we have the abstract relations between those contrasts between phrases, and we can also connect phrase groups and sections and songs. If we go even further down into the audio data, we have the problem of mixing. That's also a very difficult problem, where you have to consider how the ear actually hears everything. So if you add a new part, it kind of makes it difficult to hear those parts. So you have to create this. Anyone who's done mixing know that you have to kind of ride the gain, so to say, sometimes to make the different stems of the audio adapt. And then we have mastering. These are not, I'm not so familiar with this domain, but I have someone to help me out there. Charles Elmy, he's a professional music producer. So he has many millions of streams on Spotify, so he really knows all this. And we're going to have some sessions and try to solve these difficult problems. Okay, some applications of this music AI then. You can use it as a tool and maybe have it as a plugin in a digital audio workstation. You can also have it as a standalone tool for creating complete songs that we did before. And you can also use it as, if you're a composer yourself, you can create, maybe you get a lot of tedious work, that you always get these requests for creating certain types of song that you really don't want to create. You want to create different songs, but then you can create a song, this template that will take care of it, most of the work for those. You can also use it for example, YouTube. If you upload a video and you want some unique music, so what if you could integrate it into that platform? That would be interesting. So you can have your own unique songs, because you tend to hear the same songs all over again on YouTube. But here you also have the possibility of customizing the length to in more detail, and the style. And if you want a part of your video where something should happen, for example, you can just drag a slider in theory and say that here something should happen with the music, because here something interesting in the video happens, and then you move things around. Then you should just move the slider, and you get the point for the music to happen in that spot instead. So, yeah, in theory. So that would be really cool. Games, of course, you can have it use this system as an API. So inside the game is calling this API and creating new songs, but they still fit in the context that you're in the game. So you never get the same repeating songs. Also, if you have users that creating levels, you can expose this to them so they can give their own unique touch on their levels. And expect a lot of silly things this can be used for. It's very auto-tuned songs, and looking forward to see that. Here at the East Sweden Game, I'm working on this called WaveBots Hub. It's a kind of a server where you can have user-generated templates and user-generated songs. You can have interaction playlists, and then you have this kind of client where you have games and visualizers, and you can buy music from it, unique music, for your application. But you can also have a lot of fun with it. Then if you get real skill in creating this song template, you can even make money by selling the content of the songs. If the music gets really good, you can create a streaming solution as well, which is very interesting, because you can create randomizing the songs, not just randomizing the order, randomizing the entire song, so you can get unique music. This you can use in gyms and shopping centers as well. So if you get the optimal training music or the optimal shopping music, so makes everyone happy and shop a lot. Here, externals. If you have perfect explosion sound effects generator, for example, you can couple your server to this WaveBots hub and sell it, because we provide the visualizers and games where these explosion effects can be used. And also, if you're a researcher, you can maybe have this perfect jazz melody generator, but you can't really demonstrate it on any platform. Then we can couple it to this as well. Maybe not selling that, but still create some hype for the research. So we can, and also supporting hosted. This is a vision, so I'm going to scale back everything and create the first version of it, which I'm working on now. It's a client. You can only play one game, but you will be able to buy music and create your own songs, and also sound effects. So you can get music and sound effects that maybe fits your application. It's going to be very narrow in the beginning, but we're going to expand the songs it can generate. So we get outside this retro domain. Okay, so now I'm just going to play some songs from this system that's been generated, and then I'm going to show at the same time part of this hub that I'm creating with the game. Okay. These are all composed by WaveBots. Oh. This is a test game where to the right there you can see the different clips that you can try out, and you can randomize them. And you can also randomize the songs that the game uses in different situations. So here you can get your own unique collection of sound effects and music, and they will fit together in theory. So they will work together, and even if you change the scale of everything just adapts to it. Trying to make it so general as possible, so you can have both combat and platforming. So hopefully it fits your retro game better. It's just a demonstration. But the idea is to create several of these games and visualizers, so you can maybe find your project music there easier. The next game will probably not be some retro game. It's going to be some more modern looking. So you can see also when you can edit all the settings of these songs, but it's on a much higher level of abstraction than you saw in the other editor. If you could read the fine print of that before. So that is what I have right now with this for the Procedural Music Hub. Yeah, this could end. What?
We have time for some questions.
Yes.
Do you have any questions?
In Swedish, it's fine as well.
You didn't touch upon sound effects. How does this WaveBots optimization problem play into sound effects, which are much shorter?
Yeah, they are often not used. They're only sound effects. Sometimes you can create a more rhythmic sound effect, or that's playing some kind of melody and so on. Then you have this figuration that it's off. The voice leading is non-existent unless you have some kind of ending song that's short as stingers and so on. You can use some parts of AI is used. Otherwise, it's more just instrument design and finding good parameters for the sound effects.
Thank you.
Wouldn't like an AI generated voice sound fake or whatever you're supposed to say? Like it doesn't. Like if it sings about like a loss of a friend, but since it's artificial intelligence, it doesn't have feelings, so it doesn't make it. Do you get what I mean? Like it doesn't feel real or whatever you're supposed to say.
Yeah, that's a good question. It kind of depends. A lot of music that we hear are not really any real instrument, real instrument, because you can make some very good physical models, for example, of strings and so on. For the voice, it's much more difficult to have it sound natural, but I think it's doable. But at first, you can just call it creativity and say that this sound should sound robotic so you can create a lot with that as well.
Yeah.
Hur lång tid tar det att generera en sång när man väl har ställt in alla inställningar? Så är det instant eller måste man vänta en stund?
So the question was how long it takes to generate a song, and it depends a bit on the length of the song and how many constraints you have set up. No, it also contains depends on the what synthesizers you use. If you just use MIDI, for example, it goes much faster to generate. So it's always faster than real time. But it's quite resource intensive, so it uses many threads. So if you don't use just a single thread, it probably sometimes it's double time the real time. So, but MIDI always within 10 seconds and so on, like a regular song, I think, with on a regular computer.
Yeah, I think I have two questions. So first of all, with this setup, you are sort of constrained to MIDI sounds. Have you had any plans or thoughts about doing some sort of hybrid system, so you have like parts of a song actually recorded on strings and then combining them in different ways, so it's not fully random, but
yeah, if you could, I had that idea actually when trying to add some vocals to it, and then I analyzed the frequencies and so on, and that procedure can also be used for taking a sample, whatever, and then analyze it and trying to find it's quite tricky to find the chords and so on, but it's doable, so it could work. And if you have some manual interaction with it, then it's absolutely doable.
That's a good question. Have you had any thoughts on incorporating this into a real-time system? For example, when Rockstar did the first Red Dead Redemption, they recorded hundreds of hours of music and then they connected that to different parts of the game. If you're on a horse, they had special soundtracks, and if you started shooting, they had some soundtracks, and everything worked together. Have you had any thoughts on like incorporating WaveBots into a game so the music reacts, or is that not possible?
It's this is more of an offline system since it's using mastering and all that. So but it's possible to compose several different variants of it that sound good together. So then in game you can pick between the different sets that sounds good and it works within the context. So it's possible, but it's probably maybe better to use something more dynamic than I don't know. I guess the real question is if it's good enough, if it's adds something to the game. Yeah.
So with intellectual property rights, if someone uses WaveBots to generate a song, do they have the rights to the song?
We had some discussion about that. We had a law firm taking a look at it, and they say that the one who writes the algorithm owns the rights to the output. At least can claim the rights to it. We can decide just to say that it's public domain and so on. But probably aiming for non-exclusive rights. So you can get this song and use it, but you don't get exclusive rights to it because someone else might use the same input or different input and get the same song. And if they claim exclusive rights, then it doesn't work. Then
Because you could mine songs then. You could like have a computer that generates songs and then you own them. So you could like claim as many songs as possible. And then you have a hoard of rights. And someone's like, I've written the next hit. I generated this 2 months ago.
It's we have probably when people start buying these songs, then we have to keep track of all the songs and who has the rights to them, and kind of have proof that we generated this with this algorithm and these settings and so on. So that the license is very clear what you can do with these songs as well.
I have a question around the business model connected to the thing with the licenses. Do you plan to sell the tool? Like you pay one-off fee, $1,000, and then you can generate music? Or do you plan to give out the tool for free and then sell the generated songs?
The tool will as much as possible. I want to make the editor available in the client, so you can create your own song templates, and then those become very valuable because then you can take those into players and use it from within other applications. So the player for those might be free, or at least not cost so much, but the actual song templates, that's where all the creativity goes into. So well, I don't know really, but it's
Sounds okay.
I also have several questions. One of them was sort of answered, which was that this is still offline primarily, so it's not interactive yet. That it would respond to what you do, and it can't improvise on the spot, so to say.
That's correct.
Right, and that's a fundamentally game changer. So you would have to change things fundamentally to be able to do that.
At least unless you create several variants of it, maybe create from a certain context you create a song with a look ahead, for example, and then you create, depending on what happens, you can compose them beforehand, 3 variants, for example, if they happen, and then you pick the one that matches the best. So you can use it, but it will be waste a lot of resources.
I see. So a connected question to this, to some extent, is if it's possible to use this algorithm somehow to learn from existing compositions and sort of say these are all very. So you have Bach as the example. Could you take all the fugues he ever wrote and sort of learn things from them that you then could use to enhance your algorithm?
Absolutely. There are many abstraction levels in this, as you saw, with many problem domains, and all of them use almost all of them use some kind of planning algorithm. And what the planning algorithm tries for different solutions, that is controlled by likelihoods or probabilities. So if you learn, for example, how Bach did in a certain context, if you find a good representation for it and can actually get those likelihoods, you can get those likelihoods into the WaveBots system on that abstraction level, have it mimic how Bach did it.
Right, but you would need to develop such a sort of translation from the raw music to the structures that this can understand and then get the likely.
Yes, yes. Either it has to be marked some way. In some abstractions are easier, like the next note, for example. You can almost just analyze it immediately and then plug it into the figuration system, so you can get different settings for different types of styles and songs.
I have a final question, which has to do with visualization. So this is something I'm interested in sort of having a visualization of the music to understand the structures that you hear by looking at them. And in here it seems like you have already started to create an underlying structure of the music. So instead of sort of generating only notes, you should be able to generate both notes and a visualization so that you can see what happens.
Yes, yes.
Is this something you have gone into or are planning to do?
It's my output. When I debug or find bugs in the system, I generate a very large HTML file that contains a lot of these images of how everything is connected and so on. It's not dynamic, but it's kind of shows all these with images. So I already have some visualization for debugging purposes. Some of these images with notes are actually part of that HTML file that you output. But you maybe wanted some more dynamic, more...
Yeah, so I'm a choreographer, so I do dance choreographers. And I'm also a classical pianist, so I do choreographies to visualize with dancing what happens in the classical pieces that I play. And I'm also into AI, so there are sort of different overlaps.
Interesting.
I had a question. Yes. In the songs we heard, you could hear a pitch bend somewhere and a vibrato. How does WaveBot choose where to put those? Is it like, since I made a vibrato here, in the next note I may not do it, or?
That works in a similar way as those abstract figuration patterns. Here you have abstract modification patterns instead. So you have modification 1, here modification 2, and then you can constrain these, how many of these, and if they should form some kind of pattern, if they are only restricted to longer notes and so on. So you can have a lot of control over how these modification patterns. Then you map those abstract modification to concrete ones, like vibrato and so on. And that could be style dependent or depend on the actual instrument that's used as well. Some instruments don't support vibrato, for example. So then you have some other modification, like creating some grace notes and so.
But are all those parameters that you have to set yourself, or can it interplay? Since I did a vibrato in the end of verse 1, I'll do it again in verse 2, or?
Yeah, that is can also be done with constraints, but I don't think I have that kind of fine-grained control yet. But it can be added. You can say that these phrases should have the same modification pattern, for example, over this type of line. So you can create that, but right now there is no support for picking like saying. Doing that you just said.
Will you ever put in a way to, like, if you put in a predetermined chord progression, will you have like functionality for that?
Yes, or chord progression.
Yeah, predetermined chord progression.
Yeah. All of these were just picked from. There are some chord progressions that are used a lot and. Working with different styles, so you can have the procedural progression, but it's often the safest bet is to pick maybe 10 that sounds good. So and then use modifiers to those chords to have their unique style.
All right.
Have you ever sent one of those MIDI songs to a professional song composer and see what they come up with? Like, so you have some sort of goal what the program could be able to do by itself future.
So they can inspect it and check.
No, so like you send the MIDI song to some composer and let him or her like try to make something of it, try to develop it further, so that you have like a goal of what your program could be able to do in the future. I think it would be really interesting to hear.
Yeah, some kind of collaboration with the composer
exactly.
would be really
so
good.
the composer gets the core song from you, from the WaveBots, and then he or she can like develop it further.
Yeah, and say that this sounds really bad, and or this sounds really good. Do more of that, and so on.
Yeah, something like that.
I want the best would be if they actually use the tool, so that they can actually get the results themselves and play with it, and say to me, "I want to do this as well. Can you add that, please?" And then I gladly will. So.
What's your success rate on a piece? If you put in a few variables and you press enter, is that 98% chance it's a good song, or is it just, well, I need to adjust this 56 times out of 10 until you actually get something useful?
And it depends a bit on how much freedom you give to it. If you make it so the song structure is also dynamic, so you have to distribute these abstract relations over it. Sometimes it doesn't sound that good. So, but if you just create one song and if you make some changes to the progression and changes to how a build works or which parts are active, that usually sounds good. So it depends, and probably the more songs you can generate, some will be really bad and some will be good. Depends.
Yes, firstly, two questions. How long have you been working on this?
Yeah, that's a tricky question. So I haven't, at first I kind of switched between different procedural systems, and that's kind of hard. But I guess it's more than 5 years now I've been working with these different prototypes, I think.
And how can I get started?
Yeah, do you know AI, for example?
I don't know it, but I want to work with it.
Do you know music theory, or can you compose, for example? Is it?
I want to learn.
Oh. Then I suggest actually reading. It's called The Idiot's Guide to Music Theory and The Idiot's Guide to Music Composition. That's a really good introduction to how to compose music. I started there when I learned music theory. And it's really good books.
Like did you mean how you get started with WaveBots, the editor?
Just how I end up on the same path.
Oh yeah, okay. Yeah. Then the book.
Yeah, and then of course the Artificial Intelligence Modern Approach book you should read many times.
If I want to get started with your tool and try it out and play with it, is that possible? Do you have
Yes, soon. You can play it now, but it's not that well developed, so you don't. It will soon be a demo ready. So.
Any year soon.
Any year soon.
Cool.
The training data that you use, what kind of structure is it? Is it sheet music, or is it just noise, sounds, or what do you do to train the data?
There is no training data at the moment. It's just algorithms. But later I will add the possibility to use training data to tune the system.
And any ideas on how to, like, what format that data will be?
First, I guess just MIDI, but then I heard there are some databases some research databases where it's more semantically marked, but I have to look into it.
Sort of questions in the same lines, which is sort of if you could for instance, take the beginning of a piece and then do improvisations around that? And if so, how would that beginning of a piece be structured in a good way? I mean, if it could take sheet music or some version of it that's compatible with that, then it would of course open some doors.
Yeah, currently, if you could take, probably you can get the progression from the sheet music, and then you can.
You construct like a phrase, like I want this melody to come back many times with variations around it.
Yeah, you can constrain it to be like that. That's doable. You can just vary some parameters and get some kind of similar melody, and you can vary the figuration line that expresses these how many times you want. So.
And then, I mean, coming back to this training, if you could do that so that you look at how previous composers have been doing that. So how is Bach, for instance, or Mozart, how are they doing their variation pieces? Then you could have it do this variation in the style of Mozart, or in the style of Bach, or in the style of ABBA, or in the style of...
Yeah, if I can somehow extract that information and then it's possible. So it's but it's probably very hard to just.
That should be okay. So we can talk more about that.
No, I would say like copyright issues. I feel like copy like ABBA's music, or not copy, but like take melodies and stuff like from it. Wouldn't like ABBA be able to sue you for copyright infringement?
Yeah, if it kind of suddenly one.
If it sounds very similar to like ABBA's music, then it's like.
Yeah.
You get what I mean?
Then it's a problem. But then you have to write some legal stuff that if this happens, then and so on, legal terms for it.
But it's quite interesting because if you take the ABBA style, so when you listen to it, it sounds like ABBA, but it's not ABBA. It's not any phrases or any notes. It's just ABBA feeling. Who owns the feeling of ABBA? That would be interesting cases. Like same in court.
Yeah.
I hope you sleep well. Maybe we should wrap this up because you will stay.
Yes.
And if I remember correctly, you will show WaveBots here.
Yeah, I can demonstrate the system on this laptop, but it's it's many kind of complicated editor, but I can show you. It's
pretty cool. Yeah, I've seen it. It's pretty cool. So maybe we should wrap up this talk, and then you can take food in the kitchen and mingle around and stay for as long as you like, and then you can continue to talk to Per and look at the tool. All right?
Yes.
Okay.
Oh.
East Sweden Game.